Hey guys, how's it going? So today we're going to be learning something in integral calculus called trigonometric substitution, and it's a great way to solve a tricky integral. Here we go. Today we're going to solve the integral 4 minus x squared dx. Okay, and I'm going to do the substitution and solve the integral first, and then I'll go to the general case, okay? So let's substitute x equals 2 sine theta. And so x prime is going to equal 2 cos theta, which implies that dx equals 2 cos theta d theta. 2 cos theta d theta. Okay, next. Let's just plug that in. So four minus 4 sine 2 sine theta, that x squared would be 4 sine squared theta. Okay, dx would be 2 cos theta d theta. And okay, so this would be 4 cos squared theta square root. That's 2 cos theta. 2 cos theta times 2 cos theta is 4 cos squared theta d theta. Okay, now for cos squared theta, there's if you use an identity, the double angle identity, cos squared theta, there's actually a really nice formula for that. That's 4 cos 2 theta plus 1 over 2. Divided by 2 d theta. Move the 4 over 2 is 2. We can move that to the outside. So that's 2. Okay, so then let's do this a bit slower, shall we? Cos 2 theta I don't want to confuse you guys and or make a mistake. D theta. And now let's see. So this would be, okay, so that's 2. The antiderivative of the cos 2 theta, that's 1 over 2 sine 2 theta plus theta plus c. That's okay. So this 2 and this cancels out. So that's sine 2 theta. Sine 2 theta gives you 2 sine theta cos theta. Plus 2 theta Now I could write 2c, but c is any constant number, so just say plus c. Now we are partially done. We want our final answer, since we're integrating with respect to x, to be in terms of x. So we need to know, what is theta expressed with respect to x? Okay, earlier we said, here's the clue. Earlier we said x equals 2 sine theta, right? So that means x over 2 must equal sine theta. Now let's use grade 10 math and trigonometry to express what this looks like in terms of a right triangle. Okay, so I'm going to draw this. It means it's a right angle. This is theta. And remember SOHCAHTOA, sine. So this is x. And this is 2. Now using the Pythagorean theorem, this would be 4 minus x squared. This would be the square root of 4 minus x squared. Sine theta is x over 2. So cos theta would equal root 4 minus x squared over 2. Yeah, basing on this. And then theta, this is how we do it. So sine theta is equal to x over 2, which implies that theta is equal to arc sine let me think, when y equals sine x, x equals arc sine y. So how would I express this? Arc sine x over 2. Yep. Arc sine just means sine inverse. So yep, that's true. Okay, so now for the final answer, I'm going to write it like this. So 4 minus x squared dx is equal to 2 x over 2 root 4 minus x squared over 2 plus 2. I don't have space to write arc sine, so I'm going to write sine inverse. Sorry, I wrote theta, but I meant to write x over 2. So sine inverse x over 2 plus c, right, from here. That's equal to 1 over 2x root 4 minus x squared plus 2. Okay, I can write arc sine. Who cares? Arc sine. I like writing arc sine as opposed to sine inverse, because sine inverse looks like 1 over sine x over 2. That's just my personal preference, though. You can write it either way. They're both technically correct. Arc sine x over 2 plus c. And that's the answer. Hand it in, A+, gold star. So here is the general case when doing trigonometric substitution. When you have a squared minus x squared in the integral at the integrand, then basically say that x is equal to a sine theta or a cos theta. Both will work. And if you have something like a squared plus x squared, then x is a tan theta. That's the substitution method. And, it doesn't really have, a doesn't always have to be a perfect square. If a was 3, then x could be root 3 sine theta or root 3 cos theta and such. And, just doesn't have to be strictly x squared. So if it was like 4 minus 3x plus 1 squared, you could work something out from here. Just say 3x plus 1 is equal to sine theta or cos theta, right? I'm not going to write out the whole thing. And then you could substitute x equals sine theta minus 1 over 3. I'm not going to write it out, but it's going to be harder to solve this type of integral dx, but it's a similar idea. Yeah. So yeah, that's all for trigonometric substitution. I hope you guys loved this video. I love to stay, but now I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.